Okay, I was disturbed, so I have to repeat again. So, what we are trying to discuss today is a vector. And remember, I'm blind, but not a lecturer, but I'm a student just like you guys. So, I'm trying to make mistakes, but I'll try by all means to avoid mistakes. Okay, but all I'm trying to mean is I'm not perfect. I just have the heart to share. Okay, so I'm trying to cover what is known as the cross product, but before I do the cross product, I want to explain something pertaining dot product. So when you say dot product, what we are trying to mean is they're just a scalar. Having a dot product, we don't get a vector, but what we get after a dot product is known as a scalar. Okay, and you know the laws that govern this. If you have I multiplied by another I, the answer is equal to 1. J multiplied by J, the answer is equal to 1. Same to K multiplied by K, the answer is equal to 1. So, with that in mind, or with that saying, let's move. For example, if we have A is equal to this, and B is equal to this. For us to have what is known as the A dot B, we are going to say we multiply accordingly. I with I, J with J, and that with that, or by. Should I say is equal to 2 multiplied by 3, that is equal to multiplied by 3, I times I, the answer is equal to 1, and 2 multiplied by 3 is equal to 6. Then we are going to add plus. Then that is 3 multiplied by 5, that is J, because it is known, and we are going to have 15, same plus 4 multiplied by 6, which is 24. Now, we are going to say that plus that, 21 plus that, that will be 40, is it 46 or 45? Huh? Okay, 45. So the answer, the dot product of these two vectors is equal to 45. So the scalar of these two vector, what we just simply mean, is equal to 45. With that in mind, now we can move to our cross product. Same, let's say, uh, having that in mind, what we can simply mean, let's try now to find what is the cross product of the same two vectors, which is A and B. Okay, so A cross B is equal to, here now we are going to do the same. We are going to do the same. Now, we should know some matrices for us to be able to find what is this. Okay, for us to be able to find what is this. So I'm going to write the matrix table here. So we are going to get IJK, I, J, and K. Then we are going to get this. For example, if A, vector A is equal to, which is A1 and A2 and A3, then B is equal to B1, B2, and B3. Then we can have A1, A2, and A3. Then B1, B2, B3. Then, for us to have our I, what we need is J and K. So for us to have our I, what we need is J and K. And you know the matrix says is you multiply the the diagonal, major diagonal, then you subtract the minor diagonal. That is the determinant. Okay. With that said, let's have our I. Our I now should be, that is A plus B, which will be equal to, in the formula, it will look like this. It will be A2, as you can see, that is the major product, multiplied by B3. Then minus A3 multiplied by B2. Okay, that is our what? Our major product, which is I in this case. This is our I. Then we can have comma. We can have comma. For us to have J, we need I and K. For us to have J, we need I and K. So in this case, it will be A1, our major, and B3 minus, that is our major. Our minor will be equal to A3 and B1 as our J, comma. For us to have our K, what we simply need is I and J. Okay, so we are going to have as our A1 and B2 minus A2 B1. That is our K. So in this case, let's have this into practical. Let's have a practical way of doing that. So for us to have our cross product of these two vectors, what we need is this. Okay, with that said, let's say A plus B, which will be equal to now this. Okay, for us to answer it easily, we are going to have the same I and J and K. And what are we going to have? Our A is equal to 2, 3, and 4. Then it will be equal to 3, 5, and 6. That is, which will be equal to now, simply, for us to have our A, our I, what we need is J and K. In this case, it will be that and that. That will be equal to 18 minus that and that. That is 20. Hence, that is our I. Comma. For us to have our J, we need that and that, I and K, or IK, which will be equal to 2 times 6. That will be 12. Minus 3 times 4. 3 times 4, that will be equal to 12 again. Then that will be our J. Okay, comma. For us to have our K, what we need is 3 and 2 and, okay, which is now 2 times 5, it will be 10 minus 9 as our K. Okay. Hence, we are going to proceed. I've just shortened the process, but you can do it. You list this if you want, or if you don't want, you can just end there. That is now negative 2i. Negative 2i, comma, 0, which is J. Okay, and comma 1, which is K. Now we can have our negative 2i, comma K as our vector, as our cross product of the same. Okay, with that said, we can now proceed and look at just some examples, and we are going to call it maybe a day, and you can reach out to me if you have any questions. I'm be here waiting for your questions so that I can give clarity and answers. Okay, example one. Example one. The question reads now as find. The question reads as find. As find. Okay. Find the cross product of products of vectors. A is equal to 2i, comma 3j, comma k, and B is equal to I, comma 2j, comma 3k. Now, for us to do this, we are going to need the same matrix. The same matrix, which is I, J, and K, which is, we are going to list A, 2, 3, and 1. Then we are going to have 1, 2, and 3, which is now our A cross B is equal to, our A cross B is equal to, for us to have I, we need J and K, so we did, which is now 3 times 3, it will be equal to 9, minus 2 times 1, it will be 2. That is our I. Okay? Comma. For us to have our J, we need 2 times 3. So we are going to have 2 multiplied by 3. And minus, that is, let me just light 6 if you can see, because I've done some, okay. And minus 1 times 1, that is 1. That is our J. For us to have our K, we need 2 times 2, 4. Enough of map. Oh, okay. Okay. Minus 3. Okay, 1 times 1. This is our K, which is now, that is 7i, comma, that is 5j, comma, k, because that is 1. Hence, this is the product of that. Okay, that is the product of that. And in mathematics, or should I say physics, if you have 2 vectors with, let's say for example, in this case, our A as our A vector, and we have another, that is B vector, then we have an angle that is here. So for this to be, let's say if we imagine, or for these two vectors to be equal to 0, if A plus B is equal to 0, what we mean is these two vectors are orthogonal. These two vectors are orthogonal, meaning they have a right angled triangle. Meaning to say if the other one is equal to positive, then the other one is negative. For example, A plus B is equal to same as negative B plus A. This is the same. So for this to be equal to, we need to have A which is equal to 0. A cross B is equal to what? Is equal to 0. Orthogonal. Now, if we have our end pressed here, should I use this to illustrate the AND law? Imagine this is our AND. And for this to be orthogonal, what we are trying to do is we press the AND on the vector A. Now, as the AND is moving toward B, you can see the thumb moving in that direction to form what is known as this. As you can see, that is our vector A, and our AND is pointing this. So if this A were to be moved here, the B will have that direction, or move in that direction. That is orthogonal. And if we press the same AND now here toward B, as the AND is moving toward A, you can see my thumb will move downward. That is orthogonal, as it will be something like this. And the cross product of this will be equal to 0. Meaning to say, if we have our vector A cross B, then negative B cross A is equal to just the negative of that vector. With that said, I can give an example. Oh, not now. But I'll give an example if you go through my video. Okay, I'll give it. Now, calculate the product of, that is, I'm sure is known. I'll give you just as a task. And with that said, let us now show that. Let us now show that. Show that A multiplied by B plus C is equal to A multiplied by B and plus A plus C. So for us to show that these two vectors are equal, we need to have their unit vector, which is equal to A is equal to our I. As you can see, that is just 1. Then we are going to have 0 and 0. And let's say have B, which is equal to 0, our I. Then we can have our J and 0. And C is equal to our I, 0, 0, and comma K. So for this to be shown as that and that is equal to that, we need to understand the rule that govern the body mass. Although Bambi Balanda Pepdas, sorry, I use Bemba from Copper Belt, guys. Okay, here Pepdas or the body mass, we should start what is in the bracket. So what is in the bracket is A, B plus C. So for us to be able to do the right hand side, we should have what is there. Okay, let's start. Our A, B plus C is same as having just these added. So which is equal to now 0 plus 0, the answer is equal to 0, comma 1 plus 0, the answer is equal to j. Then 0 plus 1, the answer is equal to k. Hence we have this. Okay, now we are going to get this and multiply it with our a. Okay, so our a cross the b plus c is same as having our matrix here. You can do it without matrix once you understand. Okay, our a is 1, 0, 0, and our b plus c is equal to what we've gotten as 1 and 1. Then you know the laws. That is 0 minus, that is 0. You know the laws, that is our I. Okay, for j you have, that is 1, that is 1 minus, that is for j, that is 0. Okay, and for k, that is 1 minus, that is 0. So our end product is equal to 0, I, then comma, that is 1 and 1. So our a cross b, our a open bracket cross b plus c is equal to 0, j and k. With that said, we can now have this, which is a cross b, then plus b or a cross c. Okay, and should be equal to this. What is our a cross b? A cross b, let's have our matrix here, I, j, and k. Then our a should be listed as 1, 0, 0, and our b should be listed as 0, 1, 0. And what will be our a? Our I will be equal to 0 minus 0. That will be our I. What of our j will be equal to? Our j will be equal to 0, that is our 0, and minus 0. What of our k? Our k will be equal to, our k will be equal to 1 minus 0. Hence, what are we having? 0, 0, and 1. 0, 0, and 1. Now, another, that, remember, this is our a cross b, which is equal to, what of our c, a cross c? We need to have our matrix there. Okay, and what is the matrix of a, I, j, and k, which is equal to 1, 0, 0, and our k 0, 0, 1, which is equal to, our I now is equal to, our I is equal to, you can see that is 0, minus, remember if you don't get it, just ask questions, minus 0, that is our I. What of our j is equal to, our j, remember this is our j, we need 1 minus 0. What of our k? Remember this is 0 minus 0. And we have 0 here, and 1 and 0. So now we can have this plus that, which is this and that. Now we can have 0, 0, and 1 plus 0, 1, and 0. 0 plus 0, 0. 0 plus 1, 1. 1 plus 1, or 1 plus 0, 1. Hence, if that agree with what we add here, as you can see, they are all equal. Hence, this has been shown or proved as that is equal to that. I brought about the issue of orthogonals to understand this, that we also need the angle, of which to find the magnitude as well as the force. This is just the introduction of my lessons or my knowledge, but we can go further. Having that done, okay, let me just talk about the area. The area, we can use the cross vector or cross product to find the magnitude, the area. These are some areas with the cross product of the vector is associated or applied to, but there is also another application of vectors. Now the area, we can use the cross product to find the area of the parallelogram, and so to say that is just the magnitude of that vector, and we are done. Okay, but not that all. Not only that, but just depending on the nature or the question, we can apply the rules such as cosine rule or sine rule. Okay, with that said, because we are dealing with mathematics as well as physics combined. Okay, I can have a question here. Just find the area. I won't draw the diagram, but in the next video, I can have a diagram drawn. Thank you guys. If you're understanding. Find the area of the parallelogram. The word is quite long. Formed by vectors. Mashibuken. Anyway. Namba ya chilaka nokutiranisha. Wakasuba kupe.
Ndashimi achasha kuma 808.
8 uduli nachiso mugewezi. Omugewezi uja.
Umugaza eshile 7 shana. Eshile 7 kwati 740 shana.
Omba
yale fika. Ndepsha kuchati yawashana nishita. Ati amona iPhone nginashi.
Number
808.
Ukudara that the number does not exist. Nishi number ya deko kuti exist. Okay. Here is the last question. So for us to find the area of the parallelogram, we need the same. Now we are going to have the magnitude as the area of that parallelogram. So for us to find the area of the parallelogram, remember these are our vectors. We are going to need I, J, and K, and this is our A, that is 2, 3, and 1, and that is 1, 2, and 3. So our I is equal to, that is 3 times 3, 9 minus 2. Okay, and our J is equal to 2 times 3. 2 times 3, remember you need to omit that 2 and 3, that's the middle. And 2 times 3, that is 6 minus, that is 1. Okay, and our K is equal to 2 times 4. 2 times 2, 4, minus 3 times 1, that is 3. Hence is equal to 7, and this is equal to 5, and this is equal to 1. So now we can conclude that is our I and our j and our k. Now the magnitude of this cross product is equal to, it will be equal to now the square root of this, which is 7 squared plus 5 squared plus and 1 squared, and this is 49 squared plus, that is 25, then plus, that is 1. Okay, if this is added, we can have, that is 1, that is 50, and you can see that is 75. Just in short, we have 75. Hence, we can say two numbers that we can multiply to have 75 is, what are those numbers? 3 and 25. Now we can have this. We are using Sadis. And what is the square root of 25? The answer is 5. Hence we can have answer this is equal to the area of that vector. Okay, we've used our cross vector or cross product to find the area. Now in our next video, we are going to have the cross product to find the magnitude, as well as the angle, as well as other applications which are used in understanding vector. As for now, I'm just waiting for your questions and clarifications. As you can go with just one question. Just one question that I'll be needing for you, the orthogonals or the cross vector. Prove that. I'm sure you can see. Prove that. Prove that A multiplied by B is equal to negative B multiplied by A, or A cross B is equal to negative B cross A for vectors A is equal to negative 1, 2, and 3. This is J and this is I, because it is one that is K, and B is equal to, that is 4I, comma 3 or 5J and comma 6K. I'll be needing this at the end of the day.